Hey guys, this is Carrie, and this is the answer key video for lesson 8. So we're actually going to skip through the lesson because we did that in class today, so hopefully you were there. And we're going to take a look just at the group quiz. So to rewrite these these radicals with powers as fractional exponents, like these, you have to remember that when you write it as a fractional power, you have x to the power, and power always goes on top, so power of 4. And then the root, just like a plant, always goes on the bottom, so the root is on the bottom. So you get x to the 4/5, which is this one. Which of the following is equivalent to this? So the key observation here is we don't have a rule for multiplying radicals. So what we need to do is we need to rewrite each of these using powers so that we can use our power rules. So for this one, we have x to the first power divided by the third root, x to the 5th power, and when we don't put a symbol here for the root, it means the square root, which is the opposite of squaring, so it's a root of 2. So now since we're multiplying these two things, you have to remember what's the rule that we use to multiply things with the same base. And if you don't remember it, you can just think off to the side, a simpler problem, x to the 3rd times x to the 4th. Looks identical to this one, but with easier powers. So if you don't remember it, you can remember that x to the 3rd is 3x's, this is 4x's. Oh, so really it's x to the 7th, so we need to add these. So it must be that we're adding these. So when we multiply these, we add the exponents. But in order to add exponents, we need to have a common denominator. Or in order to add fractions, we need to have a common denominator. So we get our common denominator using that method, and we get x to the 2/6 plus 15/6, x to the 17/6, which is answer choice, it's none of the answer choices yet. It's the 6th root, because the root is on the bottom of x to the 17th power, which is choice 2. Let f of x equal this. Which of the following is the equation for f inverse of x? So to find the inverse, we need to switch the input and output. So let's start by writing the output in a simpler way. Instead of writing it as f of x, let's write it as y. Now we're going to switch the input and output, so our function becomes the inverse. So switching input and output gives us x equals the square root of 2y minus 3. Now all we have to do is solve for y from here, so we square both sides, giving us x squared equals 2y minus 3. We add 3 on both sides, x squared plus 3 can't be combined because they're not like terms, equals 2y. And we divide by 2 on both sides, giving us x squared plus 3 over 2 equals y. But remember, we made up this variable y. So in reality, we want to rewrite it as f inverse of x equals x squared plus 3 over 2. For problem number 4, let f of x be the function graph below. If h of c equals 4, then which of the following could be c? Tough one if you don't remember this, but inputs are always the x values, outputs are the y values. So it must be that there's a point on our graph that has x-coordinate c and y-coordinate 4. Because we don't know c, our only option is to look at the y-coordinate of 4. 1, 2, 3, 4. So there are 2 points with the y-coordinate of 4. One of them is 5, 4. And if we had to approximate the other one, it would be 7.5, 4. So it looks like 5, 4 is going to be the right one, because c would be 5 in that case. Solve the following equation for all values of x. So to solve this problem, we use inverse operations. We get rid of the square first, and we square both sides. 2x minus 7 equals, and the most common error is don't distribute the squared. When you square something, it means that thing times itself. That gives us 2x minus 7 equals x squared minus 5x plus 25. 2x minus 7 is equal to combining like terms, x squared minus 10x plus 25. And it starts to become evident that we're going to need factoring to solve this problem. So we need to start by making it equal to 0. So that gives us 0 equals x squared minus 12x plus 32. And now if you think about your factoring methods, it doesn't look like GCF is going to be helpful, but it does look like a sum and product problem, because you've got x squared alone, and you've got the 3 terms. So x times x gives us x squared, minus 4, minus 8, let's check it. They add to negative 12, they multiply to 32, so then we get x equals 4 and x equals 8. Now hopefully you didn't stop here, because this is a square root problem, you do need to plug them in and check it. So I'm going to do a quick plug-in here. If you plug in x equals 4, 2 times 4 is 8, minus 1, minus 7 is 1, square root of that is 1, 4 minus 5 is negative 1. This one fails the check. We have to check the other one. X equals 8, so we plug in 8 here and here. 2 times 8 is 16, minus 7 is 9, square root of 9 is 3, 8 minus 5 is 3, so this one works out. Completely factor each of the following. So, oh no, it's not letting me move the, there we go. Completely factor each of the following. So for the first one, it looks like a sum and product like we had before, so we set it up. And we're looking for two numbers that sum to negative 7 and have a product of negative 18. X times x. Now, negative and positive, it's going to be the bigger one is negative to make negative 7, so negative 9 and 2. For the next one, looking at these, they do share a common factor. They share 5. And they also share 3 x's in common, so we'll factor that out. 5 times 3 would give us the 15. If we factor out 3 x's, that leaves us with 2 x's. 5 times 7 gives us 35. If we factor out the 3 x's, that leaves us with no x's, so we're done. For problem number 6, kind of looks like a sum and product, but before you do sum and product, you have to realize that there is a common factor here. They share x in common, so we'll factor out the x that they share in common. And that leaves us with x squared minus 5x minus 8. And now we see we have that really nice sum and product form where we've got x squared alone, we've got a constant here. So we get the x from before. And you have to remember to rewrite that x because it's still part of the problem. And then we're looking for two numbers that... Oh, what am I thinking here, guys? 8, that's not 8. That's 24, sorry about the mistake. I think I was thinking ahead. This is going to be x minus 8 and x plus 3, and now we've got our nice sum and product combined with GCF to factor it. For the next one, maybe it's a GCF, but x squared and 49 have nothing in common. It's clearly not a sum and product because it only has 2 terms, and we would need 3 for it to be sum and product. Grouping would need 4 terms, so it's not grouping. But it is a difference of squares problem because we have a difference and both of those are perfect squares. So we get x times x to give us x squared. 7 and 7 give us 49, and we're done. Another difference of squares problem because it's a difference. These are both perfect squares. 2x and 2x, minus 5 and plus 5. For this one, it looks exactly like a sum and product, but with x to the 4th. So it's a modified sum and product. We need to have x squared and x squared to give us x to the 4th. And then two numbers that add to 81, multiply to 81, and add to negative 18. That's going to be x squared minus 9 and x squared minus 9. Now each one of these can be factored one step further using difference of squares. X minus 3 times x plus 3 times x minus 3 times x plus 3. And make sure that you factored it all the way down to the 4 factors using double difference of squares. Write the expression below in simplest radical form. So you've got the cube root of a negative. Because this is an odd number, we can find the negative, or the cube root of a negative, and it's just going to make the whole answer negative. So step 1 for me is realizing that the whole thing will be negative. So now we're done with the negative sign. Next up, when we find the cube root of something, we need to break these things down. So we'll break 24 down. 24 breaks down into 3 and 8, 2 and 4, 2 and 2. So that's 3 times 2. And what's really nice is this group of 2's is a group of 3 2's. Let's see why that's nice. Cube roots and cubes interact really well. Groups of 3 are really nice here. Cube roots and cubes cancel out. So that will give us a 2 outside. But it's negative because of this. We're still going to have a cube root. 3 is still inside because it wasn't part of a group. The cube root of x to the 15th, well, how many full groups can you make with 15? Since we're trying to make groups of 3, this is 5 full groups with 0 leftovers. So we get x to the 5th outside. And for y to the 32nd, we're trying to make full groups of 3. So this is 10 full groups to give us 30 with 2 leftovers. So we get y to the 10th outside and y to the 2nd inside. Wow, this is probably going to be the toughest one, so make sure you practice this one until you get it right. Make sure you're thinking about your full groups, because each of the full groups will allow one member of that group to appear outside. So when we had 5 full groups, we got x to the 5th outside. I'm going to continue on to the next one, but make sure you review that one. Solve the following equation for all values of x. So it's not immediately evident what we're going to need to solve this problem, but we see 4 terms that cannot be combined. Some of them have x's, so we're not going to be able to isolate x. So maybe factoring will help? So let's start by setting it equal to 0, because that's a really good idea when we have factoring. We add 2 on both sides. That gives us 2x cubed minus 3x squared minus 8x plus 12 equals 0. And now when we factor this, we're trying to think, what method do we need? Well, I see 4 terms, so I'm thinking grouping. Let's see if that works. These share x squared in common, so you get 2x minus 3. We know we need 2x minus 3 here, so we're thinking, what do we need to factor out from these two? It looks like 4 times 2 would give us 8, but we want negative 8, so negative 4 maybe. And then let's check it. Negative 4 times negative 3 is 12. So we get 2x minus 3 times the leftovers, x squared minus 4 equals 0. This can be factored one more step to x minus 2 times x plus 2 using difference of squares. And now we get 3 solutions: x equals negative 2, x equals 2, and x equals 3 over 2 when we set this equal to 0. Oops, this equal to 0. And we expected 3 solutions to this problem because our highest power is 3, so that's really nice. For problem number 9, completely factor this. So this is a really interesting one. This is a former Regents question, so I'm just going to write that really large. Because this is a former Regents question, we want to be able to do it for sure, but it is a really tough one. So since it says factor, we're going to start by trying a GCF. This is x's, this is no x's. This number and this number share nothing in common, so GCF is out. Could it be a sum and product? No, those are supposed to look like this, and that's definitely not like that. Could it be a difference of squares? No, those have 2 terms, so that's out. Could it be a grouping problem? Well, it does have 4 terms, so that looks pretty good, so maybe grouping. And could it be an a is not equal to 1? Well, those look like sum and product, but with another number here, and so that's out as well. So if this problem can be solved, we know right away that it must be a grouping problem. So we split it into 2 groups, and we look at this group, and this group shares nothing in common. And this group shares an x in common. So let's see, we get 3x squared minus 4y. I guess maybe the biggest thing we could have factored out was a 1. And then over here, this one, we factor out the x, and we get 3y minus 4. And these are similar, but they're not identical. So these cannot be a factoring by grouping problem in the way that it's arranged right now. So the key insight with this one is you're allowed to change the order of terms when you have sums. So if we switch the order of the terms, moving this 3xy, moving this negative 4y, it won't change the problem, but that would give us 3x squared plus 3xy minus 4x minus 4y. And you can start to see that maybe it makes sense to have grouped this term and this term together because they share that 3x in common. And maybe this term and this term make sense to be grouped together because they share that negative 4 in common. And so let's see if the groups work out any better when we've rearranged it. So starting with that first group, well, we put them together because they share the 3x in common. So we factor out the 3x. That gives us x. That gives us y. And now if factoring is going to work, let's see what happens on this side. We factor out a negative 4. That gives us negative 4x. And then positive times negative would give us negative 4y. And this is super nice because we've got that same factor thing that we're used to. So we get x plus y times 3x minus 4. So I think the lesson to be learned by this problem is you can change the order before grouping. if it helps. And as some insight why we changed the order, we saw that the 4s were in common here. We saw that the 3x's were in common here, so it made sense to switch them around so they were with the ones that were most similar to them. So this was a sneaky Regents problem. We'll probably have one like this as a either bonus question or long answer question on the test tomorrow, so just be ready to switch some terms if it doesn't work out right away. I hope you guys found this video helpful. Our test is actually Thursday. I kept saying tomorrow, but it is Thursday. So see you guys on Thursday.